Alright, in this video we'll talk about stoichiometry and we'll do some of the practice problems from the worksheet. Alright, this would be on the back page. Notice we need to balance this equation before we do anything else, or we won't know the moles to moles of each, the mole to mole ratio of these things. So I notice that I have, I think it's going to be a 3 over here. I'll have 6 O's and I'll have 6 O's. 2 sodium, 2 sodium, 2 chlorine, 2 chlorine. Alright, now it says how many moles of sodium chloride are produced from 145.73 grams of sodium chlorate. Well, what are we starting with? We're starting with 145.73 grams of sodium chlorate. Okay? And we need to get to moles of sodium chloride. Remember, our good old picture that says we always have to move through moles, don't we? So I'm going to start with grams of this sodium chlorate. Then I got to get to moles of the sodium chlorate. And then I have to get to moles of sodium chloride. And to get from moles of sodium chlorate to moles of sodium chloride, I just use, the coefficients from the balanced equation. So watch how we do this. So first, I have 145.73 grams. Okay, I'm going to leave it up to you to figure out its molar mass. But you're going to figure out how many grams of sodium chlorate in 1 mole of sodium chlorate. Alright? Now, if you look at this equation, for every 2 moles of sodium chlorate, I produce 2 moles of sodium chloride. So this is what I mean by using the coefficients. This happens to be 2 to 2 or 1 to 1, but you want to say 2 moles of NaClO3 for every 2 moles of NaCl. So notice how everything cancels out. The grams of sodium chlorate, the moles of sodium chlorate, and I'm left with 2 moles of sodium chloride. Alright, each time this unit moves down, doesn't it? This unit moves down. It's a clue going forward. Number 4 says, how many grams of lead nitrate are needed to produce this many grams of sodium nitrate? Well, this is what we're starting with, right? Sodium nitrate. Alright, let's do our balanced equation. Alright, if I wrote down what I have here, I have lead, I have nitrate, that's a polyatomic ion, I can leave that together. I have sodium and I have chlorine. So I have 1, 2, 1, 1. Now I put a 2 over here, so let's count that. I have 1, 2, 2, 2. Alright, so I have to fix this one up. I do that. That'll make this a 2 and this a 2. And then we should be matched. 1 lead, 2 nitrates, 2 sodiums, 2 chlorides. Alright, again, we always have to go through moles. So in this case, I have to go from grams of NaNO3 to moles of NaNO3 using molar mass to moles of lead nitrate, and this is using the coefficients of the balanced equation, right, to grams of lead nitrate using molar mass. So let's set this one up. And I'll let you fill in the molar masses, but we're setting up the T-chart for you. So grams of sodium nitrate. Now remember, that unit, I know, has to come down here. And I said I have to go from grams of this to moles. So I'll use the molar mass. All right. Now, I know that looking at this equation, for every 2 moles of sodium nitrate, 1 mole of lead nitrate had to be used, right? So this unit comes down, so 2 moles sodium nitrate for every 1 mole lead nitrate. And then finally, to get to grams of lead nitrate, this unit comes down, right? 1 mole lead nitrate is so many grams of lead nitrate. You'll figure that out. That's the molar mass. And then you're left with that unit, because those cancel, those cancel, those cancel. Okay. If 42.84 grams of iron are reacted with water, how many grams of iron oxide are produced? So I'm starting with 42.84 grams of iron. So let's balance this. I have Fe, I have H, I have O. All right, on this side I have 1, 2, 1. On this side I have 2, 3, 2. Okay, so let's come over here and let's do this for a second. That'll give us 2 of those. Now I need to get, see, when I have an odd number, that might work. I'm going to make this 3, because that'll give me 3 oxygens, but it'll give me 6 hydrogens. Well, that's an easy fix, because I have H2 over here, so I'll make that 3, and that'll give me 6. So let's double check. 2 irons, 6 hydrogen, 3 oxygen. All right, so let's go back. Grams of iron, we have to get to moles of iron, right? Then we have to get to moles. From moles of iron, we have to get to moles of iron oxide, Fe2O3. And from moles of iron oxide, we get to grams of iron oxide using the molar mass. All right. All right. Remember, this unit's going to come down. So I'm going from grams of iron to moles. So many grams of iron in 1 mole using the molar mass, right? Now, if I look at my coefficients of the balanced equation, 2 moles of iron for every 1 mole of iron oxide. So 2 moles of iron for every 1 mole of iron oxide. Whoops. Right? That's the coefficients of the balanced equation. And then finally, you'll take 1 mole of iron oxide. Whoops, and change it into grams using the molar mass. Okay? Let's move on. This is from the front page, so let's see what we get here. First of all, it looks like it's already balanced. I'm just double checking it. Yep, looks good. So A says when 0.624 moles of oxygen are reacted, how many moles of carbon dioxide are produced? Well, we use the coefficients. We're going mole to mole in the equation. So notice, every 3 moles of oxygen, you get 2 moles of carbon dioxide. This unit comes down. 3 moles oxygen, 2 moles CO2, and you'll end up with moles of CO2. Okay? Whoops, I put a C, that should be a 2. Use the coefficients of the balanced equation anytime you're going moles to moles. Let's try this. How many grams of C2H4 are needed to produce this many moles of water? All right, well, we're starting with moles of water. So we can go from moles of water to moles of C2H4 using the coefficients of the balanced equation. So moles of water comes in the bottom. But for every 2 moles of water, I get 1 mole of C2H4. And they want us to get it into grams, so now we use the molar mass. 1 mole C2H4 is so many grams. You figure out the molar mass. Units cancel, and you're left with grams. C. How many grams of oxygen are needed to react with this many grams of C2H4? All right, well, now we have all the steps we need to do. We're going to go from grams to moles. moles to moles, moles to grams. So we're starting with 2.56 grams of C2H4. All right, using the molar mass, so many grams of C2H4 in 1 mole of C2H4. Now I need to go from moles of C2H4 to moles of oxygen. So for every 1 mole of C2H4, I need 3 moles of oxygen, don't I? And then 1 mole of O2 is so many grams of O2, and you're left with grams of oxygen, which is what they're wanted. All right, I think we have one more. Okay, A. What mass of NO2 can be produced from this many molecules of oxygen? All right, well, always start with what you're given. Now, this is really not much different. We always have to change to moles. So we know that 6.02 times 10 to the 23rd molecules of oxygen is 1 mole of oxygen, right? Every single time. And we want to get to mass of NO2, so we need to go from oxygen to NO2. So notice, moles, oxygen down here, 7 moles of oxygen are needed to produce 4 moles of NO2. And then 1 mole of NO2 is so many grams. Molecules cancel, moles of oxygen, moles of NO2, and you're left with grams. B. It says 13.8 grams of ammonia would be able to produce how many moles? Well, we're sitting in grams, gotta get to moles. So many grams of ammonia, the molar mass in 1 mole. Now I need to go from moles of ammonia to moles of water. So let's see, 4 and 6, right? So this comes down, 4 moles of ammonia are needed to produce 6 moles of H2O. Oops, yeah, that's what I wanted. Oops, and that's the answer. They want the answer to be moles of H2O, right? We started with grams, the grams cancel, the moles cancel, we end up with moles. C, now we're going from grams to grams. So we're starting with 15.5 grams of water. And I believe it's 18 grams in 1 mole of water. All right, now I have to go from moles of water to moles of O2. So moles of water down here, 6 moles of water, 7 moles of O2. Coefficients of the balanced equation. And we need to get to grams of O2, so 1 mole of O2 is 32 grams of O2. Moles of O2, moles of water, grams cancel. So you see, every single time you have, when you're working with 2 different substances in this equation, you can only talk about them and compare them using moles. So if you're at grams, you got to get to moles. Then you can compare moles. If you're at molecules, you got to get to moles. All right? So take a look at these and see if you have other questions, and we'll go from there. Thanks.